Hilltopper Heritage, Western Memories. Now, unfortunately, I don't, well, yes, I do. Actually, I do. This is not as old as that. This is from a man named Hugh Mason Eyre. These are his memories. Hugh Mason Eyre is my first cousin once removed. So he was my dad. My dad was Bobby Eyre. And I'm from McLean County, which is 20 miles south of Owensboro, if you're from that area. I grew up between Calhoun and Livermore. When I was growing up, we didn't even have a stoplight. Okay, that's how small we were. There was no, since I've left, there's a subway and there's one stoplight in the entire county. Okay, so that's how small it is. So Hugh Mason he ended up becoming a professor of history at North Texas University in Denton. And these are some of his memories. I grew up on a tobacco farm in McLean County. My mother was widowed when I was 2+. We moved in with my grandparents, my paternal grandparents. So those would have been my father's grandparents that they moved in with, okay? 6 years of my elementary schooling was in a one-room school with one teacher. My high school was Calhoun, population 749, and the one county seat of McLean County. Although my mother, who never went beyond 8th grade, persistently promoted the value of education, I really never expected to be able to go to college. But then I met a girl, a Calhoun girl, a town girl, and we dated most of our high school years. Now it so happened that her mother was related, a niece I think, to Henry Hardin Cherry, so she had ties to Western. I've always theorized that she feared her daughter would marry me and be doomed to a life on a tobacco farm, and to evade this unthinkable fate, she set about to get me to go to Western. Maybe I would have gone anyway, but there's no doubt that she provided much encouragement and opened some doors for me. Incidentally, I did not marry her daughter, but that is another story. I don't mean to imply that mine was a unique situation. Indeed, a large number of Western students of that era came from very similar backgrounds. Anyway, when I arrived at Western in the fall of 1942, so you have an idea of later than this, 1942, it was one of the very few times I had been out of McLean County. I was overawed by just about everything. The 3 elderly ladies whose attic room I lived in on State Street, just a block off campus, the good people of First Methodist Church, the faculty, and most of the students. I was warmly, even enthusiastically received. In retrospect, I think I must have felt that I had died and gone to heaven. That fall semester, we were on the quarter system then, I encountered my first college history teacher, Miss Frances Anderson. She was prim, rather stern, I thought, and easily identifiable by her always perfectly set white hair. If I am to be honest, I will have to say that she was not the best to teach, not the best for the history faculty at Western, but I didn't know that in 1942. And so I was deeply impressed by her command of historical facts. But alas, I had a harsh experience with her. Up to that point, I had never received anything but top or near top grades. She scheduled our first examination for Monday following Thanksgiving. The first examination, the Monday following Thanksgiving. But I needed to go home to gather the corn I had grown that summer on my mother's farm. So I went to see Dean Grice, talk about sternness, and he reluctantly gave me permission to be away on Friday. I spent Friday and Saturday harvesting corn, got back to Bowling Green late Sunday night. By then, too exhausted to do any studying, you know what happened. Not only did I not do well on Miss Anderson's exam, I failed it. I mean a flat-out F. I had never seen one of those, at least not on my work, and I was crushed. But I rebounded, made high grades on the remaining test, and Miss Anderson very generously, I thought, gave me a B for the semester. That was my introduction to the study of history at Western. It was a story that I've shared with many discouraged students over the years, most of whom have been kind enough to believe that Dr. Eyre could possibly ever have failed a history test. And then he goes on to say he's going to tell more in another letter. I'm disappointed, to say the least. The average for this class was a 63. I don't know that I've ever had a class that did that poorly on a test, to be honest with you. And I don't know what to do. I don't know what to do. I mean, I feel like I have done everything possible to give you every opportunity. Most of you don't have to go harvest corn. Most of you don't work this hard to earn a B. There was no internet. There was no look it up, figure it out. This was when the teacher, and with Hugh Mason as well, there was a chalkboard. You got up and you better start writing. You guys have a note outline. You have tutoring. You have videos. You have everything given to you. And some of you are wasting your time and your money. If you were my kids, I would wring your necks and love you and hug you at the same time. And that's what I feel like doing to you all. Some of you probably got scared of me on Tuesday because of what I did. And I know that possibly could have affected some of you all as far as your test is concerned. The young man and I have met, and we've shaken hands, and I think he's learned his lesson. Just so all of you know what can happen when you cheat. If you haven't ever read the Western's dishonesty policy, it states that the teacher pretty much has full reign of what she or he can do. And the main choices are, you can fail that, whatever that material was, you can fail the course, or you can be expelled. Those are the choices that can occur. Now, I won't tell you exactly what has happened, but I will tell you I did not ask for his expulsion. Okay? I care about you all enough to waste class time, whether you think this is helpful or not, to share this with you. I don't know what else to do. I've thought of options, and I think it's just going to be what it is. I think the test grade you earned is the test grade you earned. I'm more than happy to meet with you if you want to go over it. But any comments? I think I'm going to shut up. Okay. All right. If you want to know how to pass the class, there is on your syllabus a statement that says how to pass this class. And if you've done that, you're passing this class. If you haven't done that, maybe you should read it. Okay? It's pretty explicit on what to do, and it's not hard, and it doesn't take a lot of time. Okay? I'll be quiet. I could preach a sermon, but I better not. All right, here's the sign-in sheet. Grab a calculator and a periodic table. For those of you that do not see your test grade posted yet, I will get those posted. Okay? I just have not had time to get that done yet. All right, so we are studying the mole today. And what two things come to my mind anytime I think of mole is my yard. I made a huge mistake whenever we added onto our house. I made a huge mistake. And I had a lot of barn clean out down at my barn, which, you know, translates to hay, straw, manure, and it's wonderful compost. It's very, very nutrient rich. And my guy who was helping me with the house, he said, hey, you don't need to go buy dirt. Let's just go, you got all that pile down there, let's just use it. And so I was like, sure, okay, let's do that. Well, unbeknownst to me, at that time, one of the things that loves barn clean out are grubs. And what loves grubs more than moles? So I basically have a haven for moles in my yard. And so my yard, anywhere that new soil, if you want to call it soil, is like a springboard. I mean, it's like angel food cake, no joke. That's how it feels when you walk on it. It's quite soft and, luxurious, except it just grows weeds. Those little, beautiful little purple flowers that are growing now, that are called weeds, but beautiful. My kids used to think those were awesome and make me bouquets out of those. That's what it grows. There's no grass. So anyway, that's what I think of when I think of moles. The other thing I think of is when I was in college, I had a mole. Well, actually, I grew up all my life. I had a mole right here, and I had a mole right here. And I don't remember, I guess I went to a dermatologist and they said this one was a little iffy. So they took this one off first, and then eventually I got that one taken off. So that's the other, those are the two things I think of when I think of moles. But that's not what we're talking about today. So let me ask this question. What if I said to you dozen? What would you think of if I said dozen? 12. That's immediately what you think of. That's immediately what you think of. What if I say pair? 2. What if I say couple? 2. So all those couple, pair, dozen, that word means a what to you? A number. That word means a number. Well, really, what we're talking about today is mole means a number. There is a number that is what a mole is in our world of chemistry. So a mole of any substance is 6.022 times 10 to the 23rd particles. Particles. So it's 6.022 times 10 to the 23rd particles. Now, what those particles are depends upon what you're talking about. So if I said to you, I have a mole of hairs on my head, which I assure you I do not have, but if I said to you, I have a mole of hairs on my head, what would I have? 6.022 times 10 to the 23rd hairs. So would the particle be hairs then? What if I said to you I had a mole? Actually, let me ask you this question. Would you like a mole of pennies? Yes, you would. Would you be sitting here probably today? Maybe if you just wanted to learn something, you would be, because you'd be smart enough to save that mole of pennies and come to school anyway and have a work ethic. But if you really had a mole of pennies, you've got a lot of money, don't you? Because what do you have? 6.022 times 10 to the 23rd pennies. That's a lot of pennies. That's a lot of pennies. So how big is this number? That's a big number, isn't it? Is that a big number? That's a lot. That's a lot. So 1 mole means that number. Now, this is a number that has been extrapolated, so it is a rounded number, so it is 4 significant digits. It will count for 4 significant digits when you're using it, so just keep that in mind. And for our purposes, we are going to use this number in calculations now, because what we know is that 1 mole of any element is 6.022 times 10 to the 23rd atoms. We know that 1 mole of any molecular compound is 6.022 times 10 to the 23rd molecules. We know that 1 mole of any ionic compound is 6.022 times 10 to the 23rd formula units. Which means that if I say to you, I have a mole of sodium, what do I have? Come on. 6.022 times 10 to the 23rd atoms. Atoms. So we are going to use that as a conversion factor. Let me go ahead and write that down. So 1 mole of any element equals 6.022 times 10 to the 23rd atoms. 1 mole of any molecular compound equals 6.022 times 10 to the 23rd molecules. One mole of any ionic compound equals 6.022 times 10 to the 23rd formula units. Now, we call this number Avogadro's number. So this 6.022 times 10 to the 23rd is called Avogadro's number. It's not because Amedeo Avogadro came up with the number, but he did a lot of work in quantitative chemistry, so we honor him by calling it his number. So that's Now, some of you may wonder, where in the world did this come from? The best explanation I can give you, it's not exactly where it came from, but it's kind of like, how did they figure this out? And I've already told you it's an extrapolated number. So have you all ever gotten your blood tested and they would give your blood count, your red blood cell count, or your white blood cell count, you know what I'm talking about? Or maybe you have livestock and you've done artificial insemination and they'll give you the sperm count. Well, the sperm count is 13 million is normal. So more than that's great. Now, can you count 13 million sperm? Do they do that? No, they don't do that. Do they count 1.8 times 10 to the 8th red blood cells? No, they don't count every one of those. So what happens is you have a sample, and they take a drop of that sample, knowing what the volume of the drop is, knowing what the volume of the sample is, and they will put it on a slide, of a microscope slide that has a grid on it, like a graph paper. It's got a grid on it. And then when they look at that in the microscope, they count the number of cells or sperm, whatever it is that they're counting, in a grid. And then they may do that for 6 or 7 or 8 grids, whatever, or in different drops out of that sample to get a good sampling number. And then they give that average, and then they extrapolate that to the entire sample size. So in essence, that's similar to how this number was obtained, because obviously you can't even count that number. You can't go 1, 2, 3, 4, 5, 6. You can never even get that high with that number in your lifetime. And so that would be kind of an idea of how it was done, just if you wanted to know. All right, so now then, what we are going to look at, and I just realized I didn't bring my 3-ring binder, so I don't have that picture that I was talking to you about, but I'll do a little kind of, no, I didn't have it yet. Let me just kind of give you an idea. I'll just write down some substances. Water, sugar. You don't necessarily have to write this down. I'm just going to show you. So water, sugar, and sodium chloride. We're going to look at each of those. Before we do that, though, let's go back. So this is converting from moles to atoms. This is converting from moles to molecules. This is converting from moles to formula units. So anytime you are doing a problem that asks you about atoms, molecules, or formula units, you're going to be using Avogadro's number, which is this information from above. Now, I know some of you don't like to write units, and some of you like to shortcut things, so I'm going to give you the shortcuts if you need a shortcut. MOL is the abbreviation for mole. That would be the only thing you could use. You can't use anything less than that. Atoms, I guess you can take off the S if you want. It's not that much better. Molecules, you can call it MOLEC, and that will make sure you know the difference between moles and molecules. And I'm not trying to be crude or rude, but I will abbreviate formula units as FU. So those are the abbreviations that I will use when I'm doing these, so that if you wonder what I'm doing, that's what I'm using, okay? Now, look at your periodic table. Does everybody have their periodic table out? So up until this point, I had told you all that the mass was what unit? Today we're going to change that. You're right, Lucas. But up until this point, anytime I ask you to find the mass of something, what was the unit you gave me? AMU, atomic mass unit. It was AMU. But now, because we know about mole, what we actually know is that the moles, 1 mole of any element has as its atomic mass in grams the mass on the periodic table. So in other words, look at carbon. Look at carbon. What is the mass of carbon on the periodic table? 12.01, rounded like I've told you how to round it to the nearest hundredth. 12.01. So it's 12.01 grams are equivalent to what? 12.01 grams are equal to what? 1 mole. Look at your periodic table. Look at the top of your periodic table, the little legend up there. What does it say? Atomic mass is what unit? Grams per mole. Grams per mole. So they actually use carbon-12, the isotope carbon-12 that has a mass of 12. Not the one on your periodic table, that's the average, but they used actually carbon-12, and that's where they discovered that every one of the elements' mass is equivalent to 6.022 times 10 to the 23rd atoms, which is the same thing as 1 mole. So now we have relationships between grams, moles, and atoms. Does that make sense? So if we're going to do a conversion between moles to mass, then we will use the periodic table and use the mass, which is now in units of grams per mole. Now, the way we are going to do all of our problems is you always, for our purposes in this class, I always want us to take it back to moles. So it's always going to be however many grams per 1 mole. Avogadro's number per 1 mole. So we're going to do it in a 2-step. Now, some of you, I know, have the ability to do it in a 1-step, but I'm not doing that. I think all of us just need to do it the same way. That way there's no confusion. It's always per 1 mole. So it's 6.022 times 10 to the 23rd units, whatever they are, per 1 mole. It's the mass in grams per what? 1 mole. 1 mole. Okay? So let's just take, and I'm going to add, actually I'm going to change this. Instead of doing the sugar, I'm just going to make it copper. That'll be simpler for my demonstration here. So copper, look on the periodic table and tell me what the mass of copper is. So 63.55 grams are in 1 mole. Would you agree with me? Where did that come from? Where did it come from? Periodic table. It came from the periodic table. So 63.55 grams are in 1 mole of who? Copper. Does anybody else that you see on that periodic table, and I'm not talking about isotopes because there could be isotopes, I'm saying does anybody else have that average mass? No. No. So if I said to you, I need you to go to lab, first of all, let's go backwards. Copper. Can we picture copper? Wire, copper wire. Can we picture copper wire? Plus, you saw copper in, did you know, you haven't seen copper in lab yet. You're going to see copper in lab, I think, next week or the next. Okay? But you've seen copper wire. You've seen a penny, a shiny, brand new penny, has, nowadays, it's not solid copper. It's actually a shell of copper. It's like a box. You know how a shirt box, you know what a shirt box looks like? You know what a box, it's a small box on the bottom and then the lid comes over top of it and makes a seal over it. You know what I'm talking about? That's like you might get a new shirt in, or maybe some Christmas presents came in a box like that. That's how a penny is made now. A penny is a round box of copper at the bottom. It's a round box of copper at the top, and it's filled with zinc. That's how pennies are made now. It's actually a shell of copper, because a penny's worth of copper is worth more than a penny. So they actually filled them with now old pennies were pure copper. But you know what copper is. You got the point now. You know what copper is. Okay. If I said to you, go to lab and bring me back 1 mole of copper. Do you have a balance in the lab that measures moles? No. So what would you do? How much? You would bring me 63.55 grams. And you would say, okay, Miss Brooks, here's your 1 mole of copper. Does that make sense? So it's weird to call it that, but that's what it is. Now, if I said to you, bring me 1 mole of sodium, what would you bring me? 22.99 grams. You see the difference? So does 1 mole of sodium look like 1 mole of copper? It doesn't, does it? It'd be the same thing if I said to you, can you please stop by and get me a dozen Krispy Kreme donuts? And also, please go by and get me a dozen gallons of milk. Do they look the same? Does that look, but is it still a dozen? Does that make sense? A dozen is a number. So a mole of sodium looks different than a mole of copper or carbon. Okay? I don't even think I need to do this. I think you get it. Now, what else, though, would this be? If I said to you, let me ask this question. What if I said to you, bring me 6.022 times 10 to the 23rd atoms of copper? You bring me 1 mole of copper, which is the same as 63.55 grams. So in other words, can I also say that this is 6.022 times 10 to the 23rd atoms? Can I say that? So 1 mole of copper is the same as 63.55 grams, which is the same as 6.022 times 10 to the 23rd atoms. Now, what if it's a compound? What if we have a compound that we're dealing with? So flip back, and it says molar mass, molecular weight, formula mass, all those terms mean the same thing. Sum of the atomic mass of all atoms in a compound. That's what molar mass is. Molar mass is the sum, that means the addition, of the atomic mass of all the atoms in that compound. So if I were finding the molar mass of water here, we have H. How many atoms of H do we have? 2. What's the mass of 1 mole or 1 atom? What's the mass? 1.01 grams per mole. What's the mass of oxygen? 16 grams per mole. So you add all that together, and what's the total mass? 18.02 grams per mole. That would be the mass total of water. So if I go back now and say, okay, I want you to bring me 1 mole of water. What are you going to bring me? 18.02 grams. Now, if you remember the density of water, how many milliliters is that? It's easy. Say it. 18.02 milliliters. Why? What's the density of water? 1 gram per milliliter. So is 1 mole of water very much? Think about it. No. 1 mole of water is not very much. What's your water bottle volume? Does it have milliliters on it? 500 milliliters? Yeah. So this bottle, when it's full, is 500 milliliters. Compared to 18.02 milliliters, so is 18.02 milliliters very much? No, not at all. So is 1 mole of water very much? Could we figure out how many moles of water are in that water bottle? Might be a good problem. We might try that in a minute. Okay? So we could do that. All right, so what else, though, is here? If this is 1 mole of water, and it's 18.02 grams, and we already did the milliliters, but that's not our topic mainly today. What else is it? 6.022, now be careful on the unit, times 10 to the 23rd molecules. Why is it molecules now? Because it's what kind of compound? A molecular, good job. It's a molecular compound. Because it is a molecular compound, that's why it has that molecule unit, okay? All right, what's NaCl? Come on, what is it? Salt, it's salt. Put it on your french fries, it's salt. That's what it is, it's table salt. NaCl is table salt. So you calculate for me the molar mass of NaCl. Calculate the molar mass of NaCl. What do you get? 58.44. So 1 mole of sodium chloride has a mass of 58.44 grams. Should be 44. 35.45 plus 22.99. So it should be 22.99 plus 35.45. All right, now, I tell you, go to lab, bring me back a mole of sodium chloride. What are you going to bring me? 58.44 grams. That makes sense? So again, does 1 mole of sodium chloride look like 1 mole of copper or look like 1 mole of water? No, they don't look the same. Again, does 1 dozen cookies look the same as 1 dozen feathers, look the same as 1 dozen gallons of milk? No, they all don't look the same. That's okay. But is it still 12, 12, 12? Yes, every time. The mass is different, but the number is the same. So now, what's my number and the unit? Come on. 6.022 times 10 to the 23rd. Now, what's the unit? Formula units. Thank you. Why is it formula units? It's an ionic compound. Do you see the difference? Does that make sense? Okay. So, again, your conversions when you're doing this. If you are converting between mass and moles, you will use the periodic table. If you're converting between moles and atoms, molecules, or formula units, you're going to use Avogadro's number. I always want you to direct it, though, to 1 mole. I always want you to do the comparison as per 1 mole. Every time, do it per 1 mole, okay? All right, go back to your notes, calculate that mass for the compound, barium phosphate. So it says calculate the molar mass for barium phosphate. Guys, you don't have to stop each time. Just do 3 times 137.33 plus 2 times 30.97 plus 8 times 16 equals. Do you get 601.93 grams per mole? Everybody get that? Okay? Don't waste time doing each one of these and adding them. Your calculator does it. Just plug it in. Okay? Yes or no on that? If you don't round correctly, you're not going to get it, okay? Everybody needs to round to the nearest hundredth so that you get it. Now, on your Achieve homework, which I have not opened up yet, I don't think. I'll remember to do that now. On the Achieve homework, you may have some that they're giving you the mass on, and if they do, use it. Okay, because sometimes they will round differently, but as far as my test and any homework extra you do, it's going to be round to the nearest hundredth, okay? All right, let's look at the next problem. It says how many grams are in 3.50 moles of barium? Guys, this is dimensional analysis. This is why I drilled you all so hard at the beginning, so that when we finally get to real chemistry, this isn't hard. What you're given. So 3.50 moles. It's barium the whole time. And you've already looked up barium just a couple minutes ago. What are you looking for? Are we looking for mass or atoms, molecules, or formula units? What are we looking for, guys? Read it. You're looking for mass. Does it say grams? So where do we get that information? Molar mass. Where do we go? Periodic table. What is the mass of barium? So it's 137.33 what? Grams per 1 mole. So where does 137.33 go? So 137.33 grams goes on top, 1 mole goes on bottom. Moles cancel, and look, you're in grams. Boom, that's it. If you've had high school chemistry, you probably did this. I don't know, they tend to, everybody does this. In fact, some schools do a huge mole day on October 23rd. Anybody have a school that did that? A couple of you? They had a huge mole day, October 23rd, because 10, 23.
Yeah, you didn't have chemistry in high school.
You didn't have chemistry in high school? Not at all? You didn't have it, or the school didn't have
The
chemistry?
school did.
Are you kidding me?
COVID.
But because of COVID, or because of...
I was in chemistry.
So you didn't get COVID. You didn't, and I know that that's part of what's happened with you guys. I know that. I'm aware of that. But I also know I've given you. I teach high school chemistry. That's what it is. What I'm teaching you is high school chemistry, and you've got to put forth effort. The difference is you're not living at home and Mama's saying do your homework. The difference is you got partying and alcohol and friends and TikTok and Instagram and Snapchat and crap, just to put it bluntly. So don't get me started right now. I was calm. Sorry. Anyway, I may talk more later, but I'll shut up. I was getting fired up there. I'll stop. Okay. Do the math. How many significant digits do you need? 3. What's my answer? 481 grams. Thank you. All right. Do the next one. See the method here? Some of you have already gotten it all done. I saw that. Good. You've done this before, and that's great, or you just understand dimensional analysis, and you got it. It's not hard. Do the next one. Flip the page and look at the next one. Okay, so what do you have on the bottom? No, on the bottom, not the answer, Lucas. Answer the question. What do you have on the bottom? 32.07 grams. What's on top? 1 mole. So 3.58 divided by 32.07. And my answer using 3 significant digits is 0.112 moles. Is that what you got, Lucas? Good job, buddy. All right, yes or no? No, not now. Not now, because the whole problem is dealing with the same substance. Okay? All right, so flip the page. Now, what's the difference in this problem and the last problem? So, are we using the periodic table? No. Why do we not need the periodic table? Does the problem say anything about moles or grams? Do they? It says moles to send them at grams. No. So what do we use? Say it. Avogadro's number. We use Avogadro's number. That's exactly right. We use Avogadro's number. So what's our given? 6.87 times 10 to the 27th atoms. Now then, what goes on? Bottom. How many atoms are in a mole of anything? 6.022 times 10 to the 23rd. Atoms, what goes on top? 1 mole. So atoms cancel, now you're in moles. Now, this is where you have to remember how to use your calculator. EE means times 10. Do not hit times 10 EE. So here's how you're going to enter it. 6.87 EE 27 divided by 6.022 EE 23. On your calculator, you should get 11408.17. Anybody get that? Make sure your decimal's where that is. If your decimal's off, then you didn't plug it in right, okay? Make sure that it says exactly this. Now, how many significant digits do you need? 3. So here are your 3. Does that 0 make the 4 go up? So you can call it 11,400 moles, or could you do second 5 or whatever it is on your calculator and do 1.14 times 10 to the 4th moles? Is either one of those correct? Does that make sense? Yes.
Could you do it on your calculator again?
Sure. Here, let me. 6.87 EE 27 divided by 6.022 EE 23 equals. Yours is a second EE. On that calculator, it's second. You have to hit second EE. Did you get it? Everybody get it? Okay. All right. Next problem. How many molecules are in 2.91 moles of carbon dioxide? Is this problem really any different than the one above it? Do you have to use Avogadro's number, or do you have to use the periodic table? Avogadro's number or the periodic table, or both? Come on, guys. Only Avogadro's number. Does it say anything about mass? No, it doesn't say anything about mass, so do it. Do it. Do you need to find the molar mass of carbon dioxide? No, why not? Do you have to have mass at all for this problem? No. If it doesn't ask about mass, don't go calculate it. So what comes next? So I've got 2.91 moles as the given. What do I put next? 1 mole where? On the bottom. What is equivalent to 1 mole? 6.022 times 10 to the 23rd molecules. Moles cancel. There's molecules. Run your numbers. significant digits? How many? What's my final answer? 1.75 times 10 to the 24th molecules. Yes or no? Talk to me. Okay, now I have another question. Now maybe you don't even understand why would I ask is it size molecule. Well, really it's an element, yes? I mean, is oxygen on the periodic table? Yes. That means it's an element. Oxygen is an element. What have I already said? I mean, on the previous page, what did it say? 1 mole of any element, it's atoms, yes? So why all of a sudden am I saying oxygen and molecules? I thought, because it's diatomic. That's exactly right. It's diatomic. It's diatomic. Oxygen is diatomic. So why is it called molecules? Make a note. O2, diatomic. Meaning, is that going to make a difference for your mass? Yes. Yes. That's going to make a difference for your mass. So it's not just O, it's O2. So what's my given? 2.85 times 10 to the 24th molecules. Now what? 1 mole is equal to what? 6.022 times 10 to the 23rd molecules. I'm out of molecules, I'm in moles now. What's my next step? Moles to grams. Where do I get that information? Periodic table. What's 2 times 16? 32 grams for 1 mole. And then you need to make a note, draw an arrow or something. O2. That's why you put 32 is because it is O2. And then run your numbers. How many significant digits do we need? 3. What's my final answer? 151 grams. Let's plug it in if you didn't get that. 2.85 EE24 divided by 6.022 EE23 times 32. Yes or no? Make sense or not? Okay. All right, on these next two are taking everything you learned today and adding what you've already learned. So it's what you learned in the past about dimensional analysis and today's new information. So you remember the little question I asked about his water bottle earlier? And we said we could figure out how many molecules of water are in there? Well, instead of doing his water bottle, we're going to say 3 quarts of water. So we're going to start with 3 quarts of water. Now tell me what kind of unit quarts is. Volume. Good job. Quarts is volume. In order to get anything out of this, to go to moles and all that stuff, what do we have to be in? Grams. How do we get quarts to grams? You have to have density of water. What is the density of water? Density of water is 1 gram per milliliter. Is this going to be a short or a relatively long problem? Long. It's going to be relatively long, many steps, but not hard. What's our starting point? 3.0 quarts. Now, you should be able to get it to grams with your past knowledge. You should be able to get it to grams with your past knowledge. Sorry, I forgot to mark off the test, didn't I? On the sign-in sheet, I forgot. It's okay. Did everybody get the sign-in sheet today? Okay, so where did you go from quarts? Guys, try it. Go find your conversion factors if they're not in your head. Quit looking at me. Go look it up. This is the part that's why some of you are failing. You won't go look. You got it. Go find a conversion sheet. You got practice after practice after practice. Look it up. You go milliliters, and that's great, Lucas. At least you went to milliliters. How many milliliters in a quart? 946 milliliters in 1 quart. If you don't know your conversion factors, then you were lost. And that's on you. Now, Lucas, what's the density of water?
1.00.
So look, what are you ready for?
Intensity.
That's exactly right. So what's going to go on top? 1.00 grams. 1 milliliter goes on bottom. That's the density of water. Now, can you do the rest of it? Grams to moles, moles to molecules. That's what we did today. You've got a problem in front of you that's similar. Try it. How many grams are in 1 mole of water? So 18.02 grams on bottom, 1 mole on top. Have we already calculated that today? Yep. And then you're in moles. How many molecules are in a mole? 6.022 times 10 to the 23rd molecules are in 1 mole. Moles cancel. So, how many significant digits do you need in your final answer? 2. Only 2. So what is my final answer? 9.5 times 10 to the what? 25th molecules. 9.5 times 10 to the 25th molecules. Talk to me. If you did not get that on your calculator, then ask me. You didn't get it? I didn't see it.
No, you're good.
Tell me how you did it. Start all over.
Well, I mean, I got the same front number, 9.5, but I got 10 to the 26.
Then clear it all out and start all over. Tell me exactly what you're putting in.
3/4 times 9.6 times 2,838.
Whoa. Where are you getting 2,838?
Oh, well, I kind of solved it across.
You
and got
can't do that.
items. Okay.
Don't do that. Quit starting and stopping.
Okay.
Okay? Clear it all. Do exactly the steps in order. So do 3 times 946 divided by 18.02 times, now tell me how you're going to put that in.
6.22. And then I have a button on here, it's times 10, or it's times 10.
That should work. Just hit times 10, 23.
Or 23, yeah. Okay.
Okay?
Yep.
Other questions? Did you get it? All right, the last one on this set. Is this one dealing with mass to start with? Yes. What do you need to take pounds to? Grams. And then is it exactly like what you've been doing? The only problem with this is what do you not have? You don't have the formula for ammonium nitrate. Anybody want to tell me what the formula for ammonium nitrate is? NH4 NO3. NH4 NO3. So try this. Try this. I'm going to come around and I want to know who some of my people are. I know, all I know most of you by is by a number, and I don't have a clue who you are, and I'm just trying to find out something. Autumn? Who's Autumn? Guys, I should not have to write the given down. You should have written the given down. And you should be looking up how to get pounds into grams if you don't have that memorized. Look on your conversion factor sheet or ask someone around you how many grams are in a pound if you don't know them. Lucas, speak up, honey. I can't hear you. Hundredth. Round it to the nearest hundredth, correct. Anytime you pull it off the periodic table, just round it to the nearest hundredth to start with. Well, if you round it to begin with, it'll end up being in hundredths. So here's the question is how do we, the molar mass here. So this would be 2 nitrogens. I'm going to just do it down here. That's 14.01 plus 4 hydrogens. That's 1.01 plus 3 oxygens is 16. And then if you do that, Lucas, it will end up being in hundreds already. What do you have for your next step? 454 what? On top, what goes on bottom? All right, so I'm out of pounds. Now what? Grams to? What did you get when you calculated that? Grams per mole. So 80.06 grams for every 1 mole. Grams cancel. Now you're in moles. What do you want to be in? Formula units. How many formula units are in a mole of anything? 6.022 times 10 to the 23rd formula units are in 1 mole. Moles cancel. Yes or no? So then plug that in. How many significant digits do you need in your final answer? Should be 3. 3 for this. I mean, it's 3. It's 3, 3, 4, 4. So it's 3. So what's my final answer? 1.71 times 10 to the what? Formula units. Good. Yes?
Why do we not have to worry about the charges?
We do. Ammonium is +1, nitrate's -1. I did. Yeah.
So big difference, we'd have to like solve it.
Okay, so on a test, I'll give you the formula. Because otherwise, if you don't have the right formula, you can't even do the question. So I'll give you the right formula. Other questions? Just so you know, not that this really matters, but when I first started teaching college in 1994 or 1998, when I came to Western, I would make them come up with a formula, and then I've gotten a lot easier, a whole lot easier. I can guarantee you in 1927 they came up with a formula. All right, now the next topic is percent composition, empirical and molecular formulas. I'm just going to start with percent composition, and I'm actually going to skip this one to start with, because I'm going to actually go to the one that's actually common sense more than this one is. If I ask you to come up with the percent composition of anything, if anything, the percent, not even percent composition, if I just ask you to come up with a percent of anything, what is basic percentage calculation? What's that mean? Say it. Part over whole times 100. Okay? So if I said to you the percent, let me do it real quick. 6, 7, 8, 9, 10. The percentage of hat wearers in this room today is 10 hat wearers divided by 60 or 53 people total. Tell me what it would be. 10, is that what I said to begin with? 10?
5.3, or 0.53.
So multiply by 100. It's 10 divided by 53. What is it?
18.5%.
Is it 18.9%? 18.9%. So 18.9% hat wearers in this room today. Does that make sense? Part divided by whole times 100. That's basic percentage calculation for anything. So if I gave you the mass of hydrogen and the total mass of water, and then I said to you, calculate the mass percent of hydrogen in water. So let me tell you that. I'm going to give you one you do in your head, okay? 88 point, I'm going to do oxygen instead. 88.8 grams of oxygen are in 100 grams of water. What's the percent of oxygen in water? 88.8%. Does that make sense? So flip your page. When I give you experimental data, which is what I just gave you right there, if I give you the experimental data, then it's the mass of element in the compound divided by the total mass of compound times 100. Part divided by whole times 100. That's exactly what you just did. Keep it that simple. So here's the example I gave you. It's suppose a 0.358 gram sample of chromium. So this is the grams of chromium. Reacts with oxygen to form 0.523 grams of metal oxide. Obviously, it's a chromium oxide. You with me? What is the mass percent of chromium? So what was the mass of chromium to begin with? Come on, it says it. 0.358 grams. What do you divide it by? The total compound, with me? Times 100, and you get 68.5%. Is that pretty simple? Pretty straightforward? Okay. All right. So, again, skip this one. We're going to do this on Tuesday. Come down and look at this one now. This one is just like that one. And by the way, you really need to bring these notes. You're making it so hard for yourself by having to write everything today. So look at this one, and there's an extra thing you have to do this problem. What do you have to find? Tell me. Who? You're right, who? You have to find chlorine, don't you? Don't you have to find chlorine before you ever find the percentage of chlorine? How are you going to do that? Subtract. Subtract. If you don't get that, pay attention here. Aluminum plus chlorine yields compound. CMPD is compound. So if aluminum is 13.43 grams, you don't know what chlorine is, but the total is 66.61 grams, then what do you have to do? Subtract. So 66.61 grams minus, and there's actually, you could have subtracted at the end too. It's up to you all, but I think this is probably easier for most of you. So this is total, this is aluminum, this will be chlorine. Yes or no, guys? Talk to me. Do you get 53.18 grams of chlorine? So now the percent of chlorine equals 53.18 grams of chlorine divided by what? 66.61 grams of compound times 100 equals. And what is your number of significant digits? How many? 4. So what is your final answer? 79.84% chlorine. Does that make sense? Okay. Now, let me show you something. Well, no, I can't. Never mind, because it takes forever. Go online. It takes me a while to log on to my Blackboard. Go online and look on Blackboard, and there are lots of extra practice worksheets already there for you, okay? I'll open your homework, but I would be honest with you, I would encourage you to do the extra practice, at least a few, before you even do the homework, okay? Just to get in the habit of it. All right, I will see you on Tuesday. If you want to look at your test, I have somebody coming right this minute, and I need to talk to them for a bit. But if you want to stop by between now and 12:30 or between 3 and 4, I will have some time then.
What happened Tuesday?
I'm sorry, what?
What happened Tuesday during the tech period? I was in
Well, someone was cheating.
I kind of got that. I was looking because I was like,